Okay, Assalamualaikum. Right, so this is our last week. Okay, the last week for this semester. Okay, and this is the last topics for your syllabus. Okay, right. Okay, alright. So for the previous week, the topics that we covered is about the chapter that we covered is about PDE, right? Partial differential equation. And the previous slide or the previous video is about analytical approach of PDE. So this PDE for this syllabus or for this subject DE, they have two approach. Okay, the first one is analytical and the second is numerical. Okay, so for the analytical, I already done it last week. Okay, you can refer to the video for the last week punya syllabus lah. So for this week, we will enter the new approach. We call it as numerical. Okay, numerical approach. Okay, alright. So basically, the classification also the same thing like the previous one. Okay, tak ada apa-apa beza pun. So what I want to mention or I want to teach you today is about the method. Okay, the method. For the analytical approach, the method that we cover or the method that we learn is a method of separation of variable. Okay, the name of the method is method of separation of variable. That one is for analytical. So for the numerical, the method name is explicit. Explicit finite difference methods. Okay, right. So this is the name of the method for the numerical approach. Explicit finite difference method. Okay, right. So, okay, inside this method, they have a few steps lah, of course. But the most important thing is the formula itself. Okay, the formula for this implicit finite difference method. So, this is related with the what we call the differential, the numerical differentiation. Yeah, the numerical differentiation is related with the numerical differentiation. Okay, you already learned this before. If I'm not mistaken, in engineering mathematics lah. Of course, I think engineering mathematics you already learned this one before. So. Okay, I will write down back the formula for backward, forward, center and so on. Okay, before we go to the formula itself, you need to know or you need to revise back the formula for forward, backward and also centered. Okay, I will write down first. Okay, right. So then we will proceed with the formula. Okay, right. So for this one, okay, you have forward. You have forward. So for forward, okay, for this method, for the explicit, just now explicit finite difference method, okay, you have du dt, and also you have du dx. Okay, du dt and du dx. Alright. Okay, ij. Okay, ij represent the coordinate for I and j. I is for x and j is for y. Okay, so for the forward, okay, u, I, j plus 1. Because, okay, usually, okay, let's say you have a graph. This is t, this is x. So, like I said before, I, j, r is represent x, j represent y or t. So here you can see that it's a du dt, right? So means that I is remain as I, but j will be a bit, j that will have a changes on j. Okay, j plus 1. And then minus u, I, j over k. Right? So k is the step size for t or for y. Whereas, okay, this one is k, the step size we denote as k for t. For x, the step size is h. Okay, so for forward, du dt, okay, u, because this is t, so means that j that have a changes here, j, uij plus 1 minus uij over k. Right? Okay, how about du dx? Okay, du dx, x must have changes on x. So, ui plus 1j minus uij is uij and then divided by h. Okay, divided by h because this is x. Okay, so this is the formula for forward. Okay, for forward, we have 3: forward, backward and centered. So this is for forward, first order. Okay, you can see this is the first order because only du dt, not d square u dt square. So this is the first order. So the forward formula for forward formula for the first order is depends on this one lah. Okay, if t means that j they have changes, if x I. Okay, so this is for forward. Okay, how about backward? Okay, for backward, okay, still the first order. Okay, backward now, if backward, okay, for backward du dt, okay, it will be okay uij. Okay, now uij is minus uij minus 1. Okay, can you see the difference? Okay, forward just now is uij plus 1 minus, minus uij. But now it's reverse, uij at the first one minus uij minus 1. And for the x, uij minus ui minus 1j. Okay, okay, right, can you see the difference, right? Okay, so now I will show you for centered. Okay, for centered first order. Okay, this three all is first order. Okay, just now is forward, backward, and now centered for the first order. So du dt. So it's centered. It's centered. So it's combination between forward and backward. So just now uij plus 1 forward, right? Minus uij minus 1 backward. Okay, it's combination between forward and backward. So this is the formula. And it's divided by 2k. Okay, so for du dx, the same thing, ui plus 1j minus ui minus 1j divided by 2h. Okay, alright, so this is the formula for centered. Okay, you have another one, the last one. Okay, the last one, the formula is centered. It's centered, but this is for second order. Second order, d square u dt square. So centered. So centered, the same thing like the centered for the first order. So you start with uij plus 1. But they have an extra. They have extra in the centered. Okay, minus 2uij plus, and then continue with the centered just now, uij minus 1. Okay, you can see uij plus 1, uij minus 1 at the back, but at the center they have an extra which is minus 2uij, and then it's divided by k square. It's not only k, it's a k square. Okay, it's a k square. So this is for centered. And this is for centered for t. So now you go to the d square u dx square. Okay, so you do it. Ui plus 1j minus 2uij. Okay, it's same. Okay, and then plus ui minus 1j divided by h square. Okay, alright, so this is all the formula that you need to know before we go to the method of finite difference method. Okay, you need to know the forward, backward, centered of the first order and also centered for the second order. So basically it's a similar like the numerical differentiation before that you learn in general mathematics. Okay, so this is the things lah. Okay, alright, so for the next slide we will for the next video we will proceed with the how to use the method of explicit difference method to solve the PDE. Okay, alright.